A little bit of a background on myself. I am the, I guess, typical NANOG attendee maybe 10, 15 years ago. I've transplanted myself into the network management side of things, try to fix things and make life easier for operators over the last 10 years. Currently focusing quite a bit on configuration management, or actually impacting the way networks work through software. And I'm also newly arrived here in the US actually, so I'm learning the ropes. And we made the decision to not only make this my first time at NANOG, but also present. So I'm a little bit nervous about that. So you guys and girls will have to be nice to me here. So what I want to talk about today is what we do about this. The dominating market leader for configuration management in the world is the swivel chair. And it's been like this forever, and everyone or anyone that will tell you the opposite is a blatant liar. Having traveled now to most of the large networks in North America, or many of them at least, I'd say that this guy, the chair, turns up everywhere. He takes different shapes or forms. Sometimes he turns up as an Excel sheet, sometimes as a printer, sometimes as a Word template, but it's all traveling over matter and not over bits and bytes. And that transition from matter to bits and bytes is, of course, one of the things that we're trying to do our best to help, and what I want to talk about today. I won't go on about this too much. Everybody knows that the configuration or provisioning world today is sorely lacking, or rather, it works fine if the frequency of change in the networks are low, the complexity of each change is small or actually being smaller over time, and if no one really cares whether you may mistype things into networks. And this turns out to be about no network in the entire world. And I think the quote on this slide here that actually came out of an operations guy a couple of weeks ago, where he said that this is not a bump or a hurdle or something that we think is a nuisance. We're constantly running into a brick wall with these things. So it's actually something that's in the way of things to come. So this is something that many people feel would be useful to try and attack. So what I'm going to talk about today is largely around a couple of things coming out of the IETF, about a networking configuration protocol called NETCONF and a data modeling language called YANG. Okay? So one of the misconceptions that I constantly get, and many people at this point have heard of NETCONF and YANG, and by having heard of, I usually mean that they have projected their own expectations on it. They don't really know what it is, but they know enough to quote it wrong. So I'm going to take you through the history and some of the details of that and what you can do with it. And actually, the interesting part of NETCONF is that it actually came out of operator meetings, actually operators coming together on the Sunday before the IETF to discuss how do we keep the internet alive for another couple of months and try to do something about the stuff that came up. So in the early 2000s, the IETF realized that no one is using SNMP for configuration, and that was the anointed protocol for configuration at that point. So when they realized that, they actually went a little bit of a roadshow and spoke to a lot of operators about requirements, things that should come out of whatever we invent to do configuration management at large scale. It took a couple of years, of course. Things like that usually do that, but in around about 2002, there was the first invitational workshops when they gathered vendors and service providers to talk about the requirements of a protocol or a solution going forward. So the background of this thing is actually, and just that it's pathetically long ago, the needs of the service providers being formalized. And it was all very well documented in today's first reading suggestion, which is RFC 3535, which is a report from the roadshow and the workshops. And there's a couple of things in here that is almost ironic to read. And remember, this is more than 10 years ago. These are very, very, very basic things. Like you want to be able to make a clear distinction between what's actually configuration and what's actually operational data, things that you can't write. None of the previous protocols really gave you that. And you want to be able to configure networks as a whole, not just singular routers or discrete devices. This might sound like basic things, but these are still stuff that we are struggling with in the technology domain. And of course, what it comes down to is basic things like there's no formal way of doing backups and rollbacks using any of the protocols preceding NETCONF. So these are some of the things. Again, this is a great read. Go back and read that if you get the time. It summarizes the situation at that point, and it's actually very, very relevant to this day. So what we did, or what that part of the IETF did and the teams around that, was they wanted to take the requirements or practices coming out of 3 sources. First of all, we have vast experiences with SNMP. And with SNMP, I mean both the protocol and the modeling languages for that. Of course, people spend an obscene amount of time in CLIs, so they know what they like in terms of structures and commands and how to do things. And we also got this set of nice operator requirements. So we try to get all these 3 together. And what we suggest here is that out of that comes the NETCONF protocol and the YANG language. So first of all, NETCONF then, it's a protocol to manipulate configuration, okay? So the stab here is not to replace SNMP or any other thing. It's to fill a gap, and that gap is the ability to manipulate the configuration or the running state of network elements, okay? Again, it comes out of the IETF. It's nowadays what's called a standards track protocols, which means that it's going towards the, let's say, the highest level of acceptance in the IETF, and it's being scrutinized to the detail, and we expect interoperable implementations and things like that. Makes a big distinction between configuration and state data. It actually has the concept of data stores. We'll go into that and why that's important. You can do configuration change validations, basic things like you can ask the router, how does this change feel to you? Is it good or bad? You can actually do transactions, and we'll talk more about that. You can filter configuration data. You can ask for partial dumps of the configuration using powerful filtering tools. You can actually stream and play back event notifications. So if you're only concerned about certain things, kind of in a publish-subscribe manner, that's support for that. And it's got an extensible procedure call mechanism, so you can define your own commands using this protocol. So we've tried to cover all the bases and all the requirements coming out of the service provider community as codified by RFC 3535. And the reason why you should care, at least if you run a network or take an interest in running networks, is that this is actually providing the fundamental programming features for any reasonably ambitious automation is in this protocol, right? No need to reinvent things or come up with new ideas. It is actually pretty full of features that allows programmers to do cool things on their network elements, and it's an existing and it's a fairly mature protocol. Of course, it's got a layering model, right? We want to make sure that this actually is something that people understand, so you will see things we will make a big difference between the transport protocol and the RPC mechanism. So there's a couple of protocol bindings or transport bindings here, out of which SSH has really come out on top, even though we see people being interested in TLS. Beep and SOAP was part of the original set, but that never took off for some reason. You get an RPC layer, so it's a mechanism to transport the actual RPCs. And you have a set of fundamental operations, and we'll go into that in more detail. So you have a full protocol stack, including transport mappings, including structure for the RPCs, and including semantics in terms of operations. Okay, so no need to reinvent things. The fundamental parts are in here. It is also built on something that I personally, and the experience we have with working with some service provider, changes the game quite significantly. It's called capabilities. So it's a way for the network elements to explain to clients in a formal fashion what they can do and how they can do things. So in terms of a NetConf session, a protocol session, we'll start off with the network element actually telling the client in a formal fashion, I support the following models, okay? I support configuration of interfaces, I support configuration of IP addresses, and also I support the following protocol features. We wanted to build a protocol that can scale from very, very resource-constrained devices that only have a minimal set of operations, all the way up to core routers that can do a lot of things. And we want that to be formal, right? We want that to be something that the client can figure out without reading offline documentation or looking in some sort of an offline database. So the capabilities are advertised by the server. There's a lot of XML here, but just the way that the server tells the client things. And the base NetConf specification has a very few mandatory things. So you can start very low with server implementations. You can make it very, very straightforward, very, very simple, and then build as you grow by adding new capabilities and adding support for new models. And another very basic concept in NetConf that's really important before we head into the usage is the story around these conceptual databases. And most of you guys and girls that have experience with routers, perhaps especially with Juniper routers, will see where this came from. So there's three conceptual databases. It's the candidate database, which by the way is optional to implement, even though it's a very useful thing, so people do use it, which is literally a scratch pad. It's a copy of the entire running state of the box, or the running configuration of the box, that allows you to make changes without impacting the running configuration. And when you're done and happy with the state of the candidate database, you commit that to the running. And that's kind of self-explanatory. It's the only mandatory database. It reflects what the network element is actually doing, or the configuration of the actual network elements. And some vendors implement the startup database. Of course, what you can do is you can copy the running database to startup. These are things that are supported in most major vendors. You guys and girls probably know exactly what that is. Also optional, and just a part of the way you manipulate configuration for these things. There's a couple of common operations, and this is really where NetConf stands apart a little bit from other protocols. Of course, I get the question, how is NetConf different from pick one? And I'll spend more time on another slide of this, but here's one of the important things to understand is that the semantics in these operations is well defined and, in my mind, fairly well thought through. So most of the things that you need to manipulate the configuration and do actions and fetch data is actually around. So you get things around data manipulation like get, which actually allows the box to dump its entire configuration and state data. Get config, that only fetches the configuration of the box, which is the fundamental operation you need for backups and rollbacks, right? You issue a get config and you get something that you can store to the side that you can then fire back to the router at a later stage. Delete config, of course, and discard changes. That has to do with databases. Of course, there's ways of setting up and closing sessions. There's the whole concept of locking, which is another thing that's very important in programmatic networking, or if you want to automate things. You want to make sure that you have a consistency model that supports not concurrent, but readers that want to do things to the same box. And these, again, are things that are part of the protocol, well described in the RFC, and fairly well implemented by the vendors. You have transaction management, which is another thing that's very important and also a fundamental part of the protocol in terms of the commit command, which actually copies the startup database, or sorry, the candidate database to the running database. You have cancel commit, and we'll talk about that later. You have schema management, and this is also one of the things that is really changing the game here. You can actually ask the router or switch, you can ask the network element to send you a full and formal description of the configuration and state data dataset, which means that clients can actually acquire that knowledge. So again, you don't have to have offline databases of MIBs or offline reading of documentation. You can actually get that directly from the router. And as I mentioned, you can extend it with your own RPC, so things like ping or reboot or anything with side effects normally works well as an RPC. So the anatomy of a NetConf session, right? So I told you that this is capabilities based, which means that there are two extremes here. And if you look to the right first, pedagogically enough, just the short version of a session here is basically setting up the transport, exchanging capabilities, and then editing the running database. I mean, the traditional way of doing things, especially with operating systems like iOS, you immediately do things to the running database. To the other side of things, for more ambitious systems, again, where programmatic features and where transaction is important, the list is a little bit longer. You need to do things like locking databases. You want to be able to make sure that you don't collide with others. You discard changes. And you want to do things like two-phase commits. And what you use for that is something that's available in NetConf that's called a confirmed commit. So it's a way of saying to the box that here's my suggested change set. Go make this happen in the running database, but if I'm not back inside of a certain time frame, roll back, right? So I guess many people in here have done what I did, taken out entire countries by mistyping things, or killed your own management session by mistyping things. Now with this feature alone, actually the router or switch will roll back to its previous version. So in terms of programmability, you don't even have to care about these things. They correct themselves. And again, these are things that are part of the protocol. It's not something you have to invent on top of it. And for the readers of this presentation, I also have included Python scripts or Python programming examples where it's useful. I'm not going to go through that as part of the presentation, but for people reading it later, of course, what we're going for here is to show that for the programmer, these things are very natural concepts and that developers, software developers take easy to. And it's not very specific to network management or to configuration management, but well-known idioms to most programming languages. So an example exchange, of course, well, I'll be brief about this. It's a way of showing that you connect first, you get the capabilities, and then you can start sending RPCs. NetConf uses XML encoding on the wire, which is something that most people don't need to care so much about because people should use libraries for these things. So this is just a wire dump of a common set of back and forth where we edit the configuration for a particular set of IP addresses, for a particular set of interfaces, and try to show that using this abstraction or this way of doing things, this will be a very few lines of code. Very few lines of code using kind of the default Python library that people uses here. And you don't have to care so much about the underlying encoding for it. So for bonus points, and this is where I personally think it starts to become very interesting. Leveraging these fundamental features of NetConf, you can literally build yourself in very few lines of code real, very strong distributed transactions, especially if you use the more ambitious implementations of NetConf coming out of operating systems like Junos. And what you do in this case is that you connect to and you lock the set of devices that you want to work with. And of course, this makes most sense when you want to provision or change configuration in environments where you need to change more than one box at a time, and where it's really important that you don't leave the network in a half-baked state, and where raising a flag and calling in an expert on a particular interface is not an option going forward. You want these things to either happen entirely, or you want to be back to a known state where you were before. So that's the kind of promise for these types of transactions. So you connect to these boxes using NetConf, of course. You use the NetConf standard locks. You edit the candidate databases, and you commit with a timeout to the set of network elements that's part of this transaction. And then if your assurance checks, maybe you want to do some bandwidth burning checks, or maybe you want to do some ping checks or whatever, if they checks out okay based on your configuration and no strange things coming up in the log, you go back and confirm the commits and say, actually have this byte forever, and we're done now. And then you copy to startups. You know that when you start up the boxes again, you're back to where you were, and you release all the locks. So if anything happens inside of this transaction, let's say that R2 doesn't respond, right? All you have to do from the client side is to kill these sessions, and the boxes themselves will revert back to a previous state. So these, again, are the fundamental concepts that's part of the protocols. You don't have to reinvent that. That makes this a very, very compelling set of technologies for people that need transactions or want transactions. So a little bit about the data modeling language that comes with this. It's called YANG. It is something that was actually also brought forward by the IETF. Actually, there was a big round of discussions on what kind of language to use for modeling things for NetConf. I won't bore you with details, but we started out by trying XML schema and distal and other things. But we realized that actually this problem space has enough unique features that we actually need something that's specific to the problem domain, not to end up with immense trade-offs towards what other languages do. And there was a lot of things that came out of, well, what I would call the graybeards of the IETF that had spent a lot of time trying to rework the MIB language, SMI, and to make that more useful. So there was a couple of things from that experience that we could take and make a natural part of YANG, so it would be something that people could take easier to. And actually the most critical thing is actually on top here. It is very human readable. Actually the #1 design criteria was that it's supposed to be SDK free. It's supposed to be readable to humans. You don't need a particular client or SDK environment to read these things. It, of course, is based on hierarchical configuration data models. No object orientation here, because we all know that there's no object orientation in the forwarding layer. None of the routers and switches are object oriented. Reusable types and groupings, of course, we want to make sure that we have a library of types that's specific to networking that we can reuse across domains. Extensibility was kind of the key coming in for most of the vendors that participated in this. Of course, we're looking for a standard set of models, but people need to be able to extend them to be able to compete. So extensibility is a huge thing, a very important aspect here, going far beyond what you could do with things like SNMP or SMI, actually. We want to be able to support operations, of course, and formal constraints, things like, actually, this is what an IP address looks like, don't let anyone else tell you something else, or you actually have to have a policy named this before you can reference things. So all these semantic validations can be expressed using YANG, which makes it, again, a very powerful tool for client developers, because there's a lot of checks you can do before you send stuff to the network on the client side. And, of course, the reason why I think you should care here is because this is a full and formal contract language coming out of your network. And this can actually have pretty interesting impacts on everything from operational documentation to test cases to, of course, client development, and just a way of making sure that your assumptions of what network elements can or cannot do is stringent. And it also, of course, goes to the heart of many problems that we know the industry has had for a long while, which is things like, if I reboot with a new version of this vendor's OS, what is the difference in terms of the parameter set that I can do? Of course, with a formal language here, you have that all to your powers. You can use text-based tools, you can use whatever you need, because it's a formal description of the data set. So YANG, just to briefly show you, YANG then describes, of course, the configuration data parameters, how many slots in this box, how many IP addresses per interface, and what's the reference integrity between policy names and the way we use them. It also describes notification content, so you can describe your notifications, what's coming in and out of those. You can also define your own RPCs, of course, or the box can tell you which RPCs it actually supports. So if we put all these things together and try to go to the core of what we think you can do here, is that, of course, by using the combination of capabilities, a well-known protocol, and YANG, you can do things like you can ask the network elements. So again, what are the models that you support? And it will tell you that it supports IP, of course, it supports IPv6, it supports interface configuration. And you can look at the local model store if you're a management system and say, okay, actually this is a new version of any of these modules, or this is an entirely new box that I've never seen before, and actually I'm missing some of these models. And then there's a formal way of saying, actually, I've never seen that version of OSPF configuration data model before, so please send it to me, and the box will send it to you in whatever format they support, preferably YANG. And you can then take that and update the applications and drivers on the management system. So the whole effort of trying to keep your drivers or scripts or whatever it is that you have to talk to the network kind of goes away based on these features that are, again, are fundamental parts of the protocol, so no need to reinvent the wheel here. And for people that actually want to know more, there's actually a great RFC 6244, called NETCONF and YANG Architectural Overview, that gives you the whole conceptual story around these things and how they work together. So that's my second recommended reading for this presentation. And this one I get a lot. Well, you know, everything you say sounds great, but I hear that OpenFlow does that, right? So my normal response is this: well, OpenFlow is something that acts by its nature on the driver layer, something that is very, very close to the hardware. NETCONF is a protocol with a set of semantics. So you can apply that, you can implement that on various layers, right? But it certainly makes most sense on things that are above the driver layer. So we see people applying this to everything, of course, from RIB-FIB manipulation, injecting static routes or managing your static routes, all the way up to the configuration management layer for particular applications. So there's a layering difference between them. I'm sure we could invent an OpenFlow that would allow you to manipulate the RIB, but it wouldn't be OpenFlow, and I'm sure we could stretch NETCONF to start doing driver manipulation or pipe switch pipeline state manipulation, but it wouldn't be very useful. And the next question I get then, of course, has another protocol, as I mentioned in the beginning of the presentation. What about $proto? And that's usually SOAP, BEEP, and REST. And so without going into details about which one is the best, All I can say is that the NETCONF and YANG stack provides the transport bindings and well-known protocols. It provides the RPC layer. It provides a set of operations that's extensible, and it provides, again, a data modeling language for content. If you look at the other protocols and some things that are not even protocols, like REST, most of these parts of the stack you will have to invent yourself, or your vendor will invent for you in a highly proprietary fashion. So that, to me, is what makes a big difference between NETCONF and $Proto. A lot of momentum. We've been around, or the protocol has been around for a long while, actually coming up against 10 years. A lot of standards organization now doing specifications for it. IETF, of course, the ONF around OpenFlow switch management, the MEF for some service management, and Cable Labs for some CCAP things. A lot of vendors. I didn't do a full-blown vendor slide here, but certainly the big ones, Cisco, Ericsson, Juniper, and Brocade in certain product lines. And I think you will see both Cisco and Juniper hammering on this over the year. It's kind of also driven by the fact that Open Daylight now is kind of based on the Open Daylight controller project is kind of based on YANG as a fundamental toolkit. Of course, we do things in this domain, and there's a number of other vendors and actual open source projects to support this. There's a number of language bindings. Of course, this, with my point of view, this is where I think it starts to get very, very interesting. We can get a higher abstraction layer for developers, for actual language people. So this far, I've seen Ruby, the Go language, Python, Perl, and Java, which should satisfy most people. I'm sure we can come up with a handful or two of others, but that should be enough to get the interested people started. There's a lot of activities in the IETF right now that you may or may not want to pay attention to. We're finalizing the TLS things. We're trying to solve discovery, so a way for servers or the network elements to actually call home using standardized means to get the NetConf session going. We're thinking about a REST mapping for these things, which is, as you can imagine, quite hotly debated. We want to do DHCP v6 options for network elements to find their manager, and a lot of efficiency extensions. We've had this going for a couple of years now, so we know where we can improve things. In terms of the language side of things, which is the NetMod working group, we have interface configuration, IP address management, the basic routing more or less done, system management and SNMP configuration coming, and the next things we're thinking about is topologies, firewall rules or ACLs, and some more basic routing protocols like OSPF. There's drafts for all these things, and feedback, I'd say at this point, is greatly, greatly appreciated. So if you have opinions about this, please have a look. Of course, there are vendors like myself that also takes this to an extreme. We've built an entire system, would you imagine, around the concept of having YAG models drive an element management system. And we're Beer and Gear sponsors, so come look us up and I'll show you what we have. It's quite something I think that will stick out a little bit compared to traditional ways of doing this, leveraging the transaction-oriented nature of NetConf and the formality of the YANG language. So that's 1 minute and 30 seconds left.
So, does anybody have any questions that they want to ask about this? We got 1 minute and 12 seconds, so let's jump to you.
Hi, Danny Kahnberg, RIPE NCC. Where's the YANG tutorial tomorrow?
Oh, that's a good one. Ouch.
Yeah, you should think about doing this and also doing it at a RIPE meeting.
I agree. Thank you. Agreed.
Yeah, go ahead.
Hi, it's Andy Davidson from Allegro Networks. I just wanted to offer a couple of comments in support of this awesome presentation. It was really, really good. To add context to the comment, we're a wholesale provider that's 100% automated with everything built around NetFlow, and customers do what they want based on their needs, and it just rolls itself out automatically. And the biggest advantage we got from this is when you're enforcing network state and behavior with code, you can actually map parts of the business process to that as well, so that suddenly, that this is the reason that everyone should go home and do this work, is because suddenly all of this, all of the times that you do things out of order in your provisioning process, it stops happening when it's just a consistent deployment of things happening time and time and time again. So there's a massive, massive business case based around future savings that you get when you do this work, and we realise them all, and it's really good.
Thank you.
Anything else? Any other questions? So the rest of the PC was asking me to point out this app that Betty emailed out about that can tell you what's going on at the conference and everything. We're just trying it out this time. And so if you've got an Apple or Android device, go ahead and grab it. And it's called Guidebook. You can search for it in the App Store and then punch in NANOG on the guide. Perfect.